Alright, so here's 1.4, solving literal equations and formula. So I'm going to do number 2, 10, 12, and 19 on your worksheet, okay? It is straight from your worksheet 1.4. I just rewrote it on my piece of paper here. Let's start with number 2. Number 2 asks us here to isolate for y. It says solve for y. And then ask us this extra piece of information here. Once you're done solving for y, plug in -3 for x and see what you get as an answer. And then when you're done, plug in -1 for x, see what you get as an answer for y. And then plug in a +1 for x and see what you get for y. Well, first I need to isolate for y before I can plug in for x. Okay, it's kind of like we have to do this step number 1 first, then we can plug in numbers for x value. Okay, so let's read what the expression is saying. I have 8x minus a 4y, and that equals -12. I really want to get my y all by itself, but I have this -4 in the front, and before that, I have the positive 8x. So before I even get close to the y, I have my 8x. Okay, if I want to move across a positive 8x across the equal sign, we need to use inverse operation, the opposite operation here. So if I have a positive 8x, I'm going to use a -8x. Okay, I'm going to subtract the 8x from here. If I do it on the left of the equal sign, I must also do it on the right of the equal sign. Okay, so let's add what we got here together so far. Positive 8x minus 8x, that's a 0. I'm not going to write it down as 0, but that's a 0. Now I got my -4y by itself. So pretty close, right? But here we have two terms that are not the same. Okay, the 12 does not have an x, so I cannot combine them. I'm just going to rewrite it. You can rewrite -12 minus 8x, or you can write -8x minus 12. Either way is okay. I'm going to write -8x minus 12. If you wrote -12 minus 8x, that is correct as well. I don't want you to panic. Now I'm almost done. Now I need to get rid of this number that is multiplying the y. This is what it's saying. It's saying -4 times y. The opposite or the inverse operation of multiplying is dividing. Now I want to divide by exactly the same thing that is here because I want to become a -1, a positive 1. So I divide by a -4. A -4 divided by a -4 becomes 1, and 1 times y will just be a y. Okay? This term right here, -4 divided by -4, becomes this invisible 1 in front of my y, and I'm happy. I isolated for y. But because I divided on the left, and the equation is like a balance, if you do it on the left, you must do it on the right, I'm also going to divide by a -4 here. Okay, the whole group that is on the top, these two terms must be divisible by -4. Now let's take a break just for a second. Let's review something. Let me rewrite it first. -8x minus 12 divided by a -4. So there we go. We successfully isolated for y, and that is exactly what they were asking us. But some of you noticed that this needs to be reduced. Let's take a moment. Let's step aside a little bit, and let's remember something, a little note from before. Okay? In 5th or 6th grade, we dealt a lot with fractions. If I have a 1/5 plus 2/5, okay, I have 1 out of 5 plus 2 out of 5. Think about pizza, okay? If you have a pizza and it's cut into 5 pieces, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I have 5 pieces. You have one piece right here. I'm going to color that. Plus 2 pieces, 2 out of 5. Plus 2 more. So here's 1 more, 2 more. You have 3 pieces out of the 5 total. So I can rewrite that as 1 plus 2 divided by 5. Okay? That's just something we learned a long, long time ago. But I want you to notice something. This 1 plus 2, I wrote it as a numerator, divided by the same exact whole number here, 5, because my pizza was cut into 5 pieces. If I can go from adding the numerator into one fraction, I can also go backwards and split it into. They're the same exact thing, right? So if I have two terms here, I can split it into the same denominator. So I can write y equals negative 8x divided by negative 4 and a negative 12 divided by a negative 4. Just like our example here, we went from 1 over 5 plus 2 over 5 to a 1 plus 2 divided by 5. And we can go backwards and split them up, and it still means the same thing. So now I can reduce it a little bit easier. I'll have y equals a negative 4 and a negative 8 can be divisible. Negative 8 divided by negative 4 is a positive 2x. A negative 12 divided by a negative 4 is a positive 3. So I split the fractions and I was able to simplify it. So there we go. I successfully isolated for x. Okay? All because of my knowledge of fractions. If I'm adding a numerator, I can put it together on the top, but I can also go backwards and split them, and it still means the same thing. Okay? Now they're asking for the second part over here. They're asking you, now plug in negative 3, then plug in negative 1, then plug in a 1 to see what you get for the y. So I'm going to do 3 separate columns here. 1, 2, 3. First, x equals negative 3, then x equals negative 1, then x equals 1. All right? All using the same exact equation here. All right, so let's do it. Y equals 2 times negative 3, because instead of an x, I want you to put a negative 3, plus a 3. Okay? And then that's going to be y equals, we multiply first, 2 times negative 3 is negative 6, plus a 3. And y equals negative 6 plus a 3 is a negative 3. So when I plugged in a negative 3, I also got a negative 3 out for y. Okay? Interesting. Let's see what we get when we plug in a negative 1. Y equals 2 times, instead of an x, we're going to write a negative 1 plus a 3. So the only thing we're substituting is the x value. Okay, we're going to do multiplication first. 2 times negative 1 is negative 2 plus the 3. So negative 2 plus a positive 3 is a positive 1. So interesting. I plugged in a negative 1 here, and I got out a positive 1. Okay? Now let's do one more time. What happens when we plug in a x equals 1? So y equals, I'm going to use my little equation again, 2 times a positive 1, and then add a 3 at the end. Okay? We're going to do multiplication first. Y equals 2 times 1 is 2, plus a 3 at the end. Y equals 2 plus 3 is 5. There you go. You plugged in a 1 for x, you got out a 5 for y. So this is a very important topic in Algebra 1, knowing how to isolate for a variable so we can solve for that. Now you can plug in anything you want for x and figure out what you get for y. Okay? So that is your number 2. Now let's take a look at number 10. Number 10 says, here's this equation. Okay, this is this literal equation. There's a bunch of variables, more than 2, and I want you to solve for p. In other words, they want me to get p all by itself. The only way to do that is to do inverse operations. Okay? So let's get rid of the denominator. If this denominator wasn't here, if this denominator was not here, it would have been so easy, because all I had to do was subtract the 3, we would be done. But the denominator is here, and it's p plus 3 divided by division. A fraction is a division, dividing by m. The opposite of dividing by m would be multiplication. The opposite of division would be multiplication. So I will multiply both sides, on the left and on the right, by that denominator that I'm trying to get rid of. So I'm going to multiply by m, okay? If I'm multiplying and dividing, they undo each other, so they cancel, okay? And we end up getting our p plus 3 all by itself. And negative 1 times a m is a negative m. There we go. That's always the step I'm going to use when I want to get rid of a denominator, okay? Now it's much easier. I want to get p by itself, so all I have to do is the opposite of adding 3 is subtracting 3. But if I subtract from the left of the equal sign, I better subtract on the right of the equal sign, okay? It has to keep it balanced. So equals a p plus a 3 and a minus a 3 becomes 0, so I get p all by itself. And negative m and a 3, they're not of the same, they're not alike terms, so we're going to have negative m minus a 3. And there's our answer. P equals negative m minus a 3. Okay? If you want to know what p, if we were asking, if m was 1, what do you get for p? We would plug it in, but it's not asking for that. I'm just saying if we were asked to plug in something for m, we would solve for p. Okay? But I am not asking that. I'm just giving you an example. All right. Number 12. It says, what is the radius of a circle with circumference of 5 centimeters? So if you take a look at a circle, remember a circle, the radius is from the center to a point on the circle. Okay, so that is the radius right there. I'm going to put the letter R for radius. They're telling me that the radius is 5 centimeters. They wanted me to know what is the circumference. Circumference is going all the way around the circle. The formula for circumference is 2 times pi times r. That's the formula. Or some people also see that the circumference of a circle is the diameter times the radius. Some people see that as well. They're both exactly the same thing because the diameter is 2 times pi. I'm sorry, it's 2 times the radius. So that would have been 2 times the radius would be the diameter times pi. Am I doing that right? I think so. All right. So I am going to go with this formula right here. The circumference equals 2 times pi times r. And then I am going to be plugging it in what I know for 5 centimeters, which is my radius. What is the radius of the circle with circumference of 5 centimeters? So I know the circumference. I'm trying to figure out what the radius is. So I know the circumference to be 5 centimeters. And I want to figure out what the radius is. So I have 2 times pi times r. And I gave you guys this formula when I gave you notes. So all I have to do, I have this multiplication times my radius. I want to get the radius all by itself. So I'm going to divide by 2 on both sides so the 2's can cancel. But I'm also going to divide by pi so the pi's can cancel. So there we go. The only thing that's going to be left over here is the radius all by itself. And I have to divide the 5 centimeters by the 2 pi. You can leave your answer that way if you want to keep it as a whole number. Or you can use the calculator. It does have a pi value. I don't want you to be scared knowing, oh my gosh, I don't know what pi is. But it does have a pi value right there. Okay? And you can also use the pi as 3.14. So this is 5 centimeters divided by 2 times 3.14, which equals the radius. All right? So if you do this carefully, 2 times 3.14, let's go over here and continue here. The radius is 5 centimeters divided by, that is 6, 2 times 3, 0.28. So we just did that in our calculator. Let me use it right here because we have decimal values. 5 divided by 6.28 equals 0.796. And that is the answer for our radius. Okay? So notice that we had to know the formula first and then be able to isolate for the radius. That is the reason why we want you to be able to isolate for a certain variable. So I divided by 2 on both sides because I want the 2 to disappear. I also divided by pi on both sides, and we end up with this. The radius equals 5 centimeters divided by 2 pi. All right? And that should help you do your homework for isolating for variables. Oh, I have one more right here. There's one more question I want to cover. Last one is number 19. Okay, so they're asking us to solve for the letter n. And there we go, there's the letter n. They put parentheses over here just to say this is a group of values, but I can remove it. I can rewrite p equals m plus n divided by -5. Okay? If you notice my previous example, how did I get rid of a denominator? How did I get rid of the denominator? Let's go back. If you wrote it down, let's see right here on problem number 10. How did I get rid of this m? I multiply both sides by the m itself. So let's go back to our problem number 19 over here. If I want to get rid of the -5, I'm going to multiply both sides, the left and the right here, the left and the right, by the denominator that I want to get rid of. So I'm going to multiply by -5, multiply by -5. Multiplying and dividing by the same number, it will undo each other. And over here we're going to end up with -5p equals m plus an n. Okay? If you remember in second or third grade, addition is commutative. I can write m plus n, or I can write n plus m. It doesn't matter. So I want m to go away. I want n to stay, because I want n to be isolated. So I'm going to subtract m on both sides. And a positive m minus an m becomes 0, and my n is all by itself. Okay? But over here, I have a -5p, and it is not alike a m, a negative m. So they're not alike terms. So I just rewrite them. -5p minus an m. If you felt like writing -m minus 5p, it is also the same exact expression. Okay? So either way, they are correct. And there we go. I got the n all by itself. Okay? Notice the steps. Again, I want to get rid of the denominator, so I multiply both sides by that denominator. And then I no longer will have fractions. Okay? So hopefully this can help you. Come and see me if you need more help, or attend math lab, please. All right, good luck, guys. Bye.